It says at the top here, my computer will work. There are 3 formulas that you need to know, and you need to learn how to, you need to use them without, you need to memorize them, right? And you know how to use them. Okay, the first one's kinetic energy, right? Kinetic energy deals with motion, if you guys can remember. So, in the formula for kinetic energy, we have velocity. So, half mass, I didn't give myself enough room here, m equals mass, right, times velocity is v squared. Okay, so when I send in emails, when I try to send you the formula, or if I put it in some kind of text digitally online, it was really hard for me to put squared. So some of you might have saw velocity, and then I put like this little thingy here, and then I put a 2. That's the same thing. So if you guys got confused with that, I'm sorry. But this is really important to remember. Don't forget the squared here. Don't forget the 1/2. I know when we've been doing this, some of you guys have been forgetting something here or there, and you get a completely different answer. So, kinetic energy equals half mass velocity squared. Kinetic energy deals with motion. Remember that. That's very important to remember. The second formula to remember, I'm not going to go over these because you guys should be able to go over them. The question will ask you specifically, find the kinetic energy of this car if it's going 30 miles an hour and has a mass of 2,000 kilograms. You should be able to plug those in and find the kinetic energy. It's pretty easy, right? Plug in 2,000 here, plug in 30 meters per second. I would square these two together and then multiply the 2,000 times 1/2, which would be 1,000, basically, right? It's like just divided by 2. And then you're going to multiply the whatever you get for this answer for mass times 1/2 and velocity squared. You multiply those two together and you got your kinetic energy. That easy. All right? Second formula. Let's just erase this one. Second one you need to know is potential energy. Specifically, gravitational potential energy. That equals mass times gravity times height. Okay? So things that are similar here is we're dealing with mass again, mass of an object. We're dealing with gravity. Gravity is always the same. It is 9.8 meters per second squared. It is a constant, never changing, okay? Unless you go to a different planet. And then the height. So gravitational potential energy is not dealing with motion like kinetic energy. It is dealing with position. So how high you are on a cliff, okay? So remember that gravitational potential energy deals with position. Got your mass of an object and you have gravity. So your problem might ask you, what is the gravitational potential energy of that man standing on top of a high dive when the guy weighs 80 kilograms and he is 10 meters off the ground? Okay, so he's 80 kilograms, he's 10 meters off the ground. And you're saying, oh wait, but what's gravity? It didn't give me gravity. That's because gravity is the same every time, guys. Gravity is 9.8 meters per second squared. Okay, don't forget that. So all you have to do is multiply all 3 of those together and you got your gravitational potential energy. I didn't go into the other, so you can rearrange the kinetic energy problem to solve for the mass or velocity. Your test is not going to make you do that because they get a little bit confusing with the squared. You got to do square root and things like of that nature. But your test will ask you, what is the mass? It will give you a gravitational potential energy, and you have to solve for a mass or a height. Okay? So all you have to do there, let's say we have to solve for mass. Let's say the problem says a man with a gravitational potential energy of 20,000 joules, because energy is in joules. Let's say he has 2,000 joules of energy, and we are looking for mass. Okay, gravity is 9.8, and let's say the height off the ground is, let's say 10 meters again. All right, so what we can do is we can multiply these together here. 9.8, you can smooth this over and it'd be 98, right? Times 9.8 times 10 would be 98. And then you just gotta get over to this side. So you divide by whatever you have here. So you divide by 98, and then you get over to this side, divide by 98. Okay, I got 98 because I multiplied 9.8 times 10. Just gotta move the decimal over to 98. After you multiply those two together. Okay, and then you divide by 98, divide by 98, and then you have mass by itself, how you want it, and then whatever 2,000 divided by 98 is, okay? Okay, you can do the same thing with height. Doesn't really change much as it does with mass, right? So if you had 2,000 joules, and let's say we have a mass of 50 kilograms. Okay, you would divide by 50, and then you get over to this side, and then whatever you get, you can divide by 9.8, divide by 9.8. So you can divide by all this at the same time and shift it over here and then do it over there. Okay, pretty easy, right? You guys should know how to do that. We've done a lot of this all semester, right? Just rearranging a formula. If you guys have any questions, let me know. The last formula you need to know is work. And work is, by definition, is force over a distance, right? Multiplied over a distance. So work equals force times distance. Okay, so work is also in joules, force is in newtons, distance is in meters. Okay, so it might say how much work is done if you apply a force of 50 newtons over 10 meters. Okay, so 50 newtons of force over 10 meters. All you have to do is multiply 50 times 10, and you get how much work is done, which would be 500 joules. Okay, that's pretty easy as well. Just make sure you understand each one by definition as well. Kinetic energy deals with motion, potential energy deals with position, work deals with force over a distance. Getting into the terms that you need to know. Energy. If you guys remember, energy is the ability to cause change. So you're putting energy in something and you're causing a change, right? I apply energy to this book and I'm able to lift the book up. Okay, I'm putting energy into it. I'm applying a kinetic energy, right? Because this is a velocity, right? Into the object. So the second one is, and energy is always measured in joules, no matter what type of energy it is, whether it's kinetic, potential, and then all the different types of potential energy. There's gravitational potential, elastic, chemical, radiant, heat, electrical. I mean, there's tons of different types of energies, right? Potential and just energies. Kinetic energy, potential energy, we've already gone over those. There's three types of potential energy you guys need to know. First one is gravitational potential. We've already talked about that with the formula. It deals with height or position of an object. So we're dealing with gravity as well. So we're talking about things falling. So when we're also talking about things falling, let's say we're on this diving board here. There's some water down here. When we are up here at this height, we have potential energy, right? When we jump into the water, every millisecond that we're falling into the water, our potential energy is being converted to kinetic energy. Okay, so up here at the top, when we're not moving, our potential energy is at its highest. When we're going our fastest, right here at the bottom, our kinetic energy is at the highest and the potential energy is at the lowest. Some of you guys got confused with that, with the assignment that we did was it last week? So if we're talking about a swing, let's say we're talking about a swing set, and there's a person swinging here, and then let's just say they could be up here swinging, and then they could be over here swinging, whatever, okay? Where would their potential energy be greatest? Well, let's think of the formula. The formula deals with height, right? Deals with position. So if when the height is greatest, that's when their potential energy is greatest. So potential energy would be greatest here. It'd be the second greatest over here. And then it'd be the lowest here, right? Kinetic energy is always the opposite of your potential energy. So your kinetic energy is going to be greatest here at the bottom, because at the bottom of your swing, if you remember, kinetic energy deals with motion. You're going the fastest at the bottom, okay? Kinetic energy is greatest here. It's like second greatest or second least here. And then here at the very top, it's your least, of course, because your potential energy is greatest. Okay, also dealing with kinetic energy. Shoot, what was I going to say? Something really important I had in mind. Maybe I'll get to it in just a second. Okay, next is elastic potential energy. Oh, yeah, that's what I was going to say. Okay, so the only way you get kinetic energy to potential energy, the only way you can go from kinetic to potential is if you increase in height, and while you're going up in height, you're slowing down, okay? So while we're going up in the swing, going up to the top, we're slowing down and we're going higher. That's how we're converting kinetic energy to potential energy. It seemed like on another one of the problems we did, or the assignments on the conservation of energy, you guys were confused with kinetic to potential energy. So we can also convert kinetic to potential if we throw a ball in the air. So let's just say I'm throwing a ball. My great stick figures. I throw a ball up in the air, and then it comes back down. Right here, when I let go of it, that's when the kinetic energy is at its greatest. Okay? And this is the only way I'm converting to potential energy, is when it's going up in height, my potential energy is getting greater, greater, and greater, and up here at the top, my potential energy is at its greatest. So that means its kinetic energy is at its lowest, and then it comes back down, so the potential energy switches back over to kinetic energy, and right before we hit the ground, we have a lot of kinetic energy, because kinetic energy deals with motion, right? Elastic potential energy, that deals with like a rubber band. So when you stretch a rubber band, you're gaining elastic potential energy. The more you pull it back, the farther it'll go when you let it go. Okay, it's easy. It'll switch over that kinetic energy and go flying. Elastic energy, potential energy can also deal with a ball. If you squish a ball, it's gaining potential energy by squishing it. It's elastic, right? And then it'll bounce back up off the ground. Chemical potential energy, that deals with cars, right? Cars are breaking down in the chemical bonds in gasoline and using gas. We also gain energy from eating food. Those are just a couple examples of chemical potential energy. A system is anything around you that you can imagine a boundary. Okay, you can imagine something converting, let's say a system converting energy to another system. If I'm hitting a baseball, I'm converting energy from my bat, which could be a system, to the ball, which is another system, right? So I'm converting that kinetic energy from the bat to the ball, and the ball is going to go flying, right? Temperature, pretty self-explanatory, right? It just, temperature is basically thermal energy, right? The more energy you put into it, the hotter it's going to get. Thermal energy. Work, we've gone over that, and its units in joules, just like energy. Law of conservation of energy states that energy is neither created nor destroyed. Okay, remember that. And that the total amount of energy in the universe is expanding, right? or it's the same. Sorry, it's always the same. Conduction, convection, and radiation. That's what we just went over this past week. Conduction, these are all transfers of energy. Conduction is the transfer of energy through solids. So when I put a pot on the stove, let's use another example. Let's say I have a bowl of hot soup, right? That bowl of hot soup, and then I put in my spoon into the soup. The heat is going to travel up the spoon, right? So the spoon can even get warmer even where the spoon isn't touching the soup, okay? Obviously, the spoon inside the soup is going to be hot, but it's going to work its way up the spoon. If you put another solid, like a pot on a stove, it's not just where the stove and pot are touching that's going to be hot. Parts of the pot is going to be hot as well, because the energy is going to move up through the pot. Convection energy is the transfer of energy through fluids and gases, so like air and water. So when something gains a lot of energy and it heats up, so like still talking about convection, the molecules are going to be moving faster and faster the hotter they get, and they're going to collide with another molecule that's cooler and doesn't have as much energy and doesn't move around as much. So when it hits, it's going to transfer thermal energy. The last one is radiation. So talking about like a fire, you don't want to put your hand above a fire, right? That'd be like convection energy. Heat is like transferred upwards. But radiation, you can feel the heat all the way around the campfire as well, because the heat radiates around you. Okay. So basically it's self-explanatory. Basically. Katie, can you grab the papers behind you? Okay, the last one. No and potential energy and kinetic energy are at their lowest and highest in different situations. Okay, so we talked about that with the swing set, with me throwing a ball, and so forth. Let me just take a look on your test here. Oh yeah, and radiation deals with electromagnetic waves, like those in light, okay? I think that's basically it. Also remember, in the formula for gravitational potential energy, gravity actually has, so gravitational potential energy, this falls down so much. We have mass in kilograms. Gravity is actually in newtons kilograms. Okay. And height is in meters. And that is in joules. Okay. I don't really have much time to explain this how, but this still comes out to meters per second squared.